We started working today in the form of equations in ax plus b equals c. And I just wanted you to think about where this came from and who cares? Like, why is it important? So this is what an algebraic linear equation looks like when graphed. And this might be the real use of some kind of a linear equation. So we had a great discussion about businesses and companies and using linear equations to make predictions about their company's future success or decline, and how we can use a mathematical model to make predictions. So where it came from is Rene Descartes, and he was this philosopher and mathematician, lived a long time ago in 1637, and he came up with this way that we can relate the relationships amongst different numbers and do it really efficiently. So he's the one that is credited with saying, all right, let's let A, B, and C be numbers, and X is the unknown variable. He did a lot, Descartes did a lot of things, but this is just one thing that relates to what we're doing today. So what I want you to notice that this looks a lot like this. And you've been graphing these, you've been putting this into your calculator. If we just switch the sides of the equal sign, this is what this looks like. This is ax plus b equals c. So we're just changing c to y, and you've graphed this a lot. Y equals a half x plus 5, or y equals 2x minus 7. These are all linear equations that we've been working with all year. So when we look at a, b, and c being three different numbers and x being the unknown, there's a process by which you can find x. And that's we're saying, think of it like this. I'm thinking of a mystery number. If you double it and add 3, the result is 11. So think about how you'd go work backwards to get to what my mystery number is. Well, what did I have before I added 3 to get 11? It must be 8, because 8 plus 3 is 11, which means this is equal to 8. So what did I have before I doubled it? Well, I have to take 8 and divide by 2. And that's how I can unwrap it to find that x must be 4. 4 times 2 is 8, and 8 and 3 is 11. So this looks just like a linear equation because it is. And notice when we have a value for c or y, same thing, there's only one solution. And in this case, it has to be 4. But when we take out 11 and we just put in c or y, there are infinite solutions because I can infinitely put any value I want in for x, double it, and add 3 and get a value for y. And these x, y's are the ordered pairs that make the line when I graph this. So because numbers are infinite, I can forever choose any value from the set of real numbers for x. And when I double it and add 3, I will get y. So my value for y depends on what I put in for x. So x is my independent variable and y is my dependent variable when I graph that linear equation. So you can solve all equations in this form with just 2 steps. Undo your addition or subtraction. So just add or subtract from both sides. And the second step, just multiply both sides by the reciprocal. Now you're used to undoing multiplication with division, but that's the same thing. So if I'm going to divide by 2 on both sides, that's the same thing as multiplying by the reciprocal of 2, which is a half. So when we solved this one, we subtracted 3 from both sides, and then that reciprocal of 2 is a half. I could just divide both sides by 2 and I'll still get 4. But when you have a fraction, it's easier to think about the reciprocal of that fraction. And then you always show a check. And we applied these two rules to some equations where a is a fraction. And that usually scares you guys off, and I just want you to see it's not hard. It's the same 2 steps. So we're going to undo the subtraction by adding 53 to both sides. And then we have negative 3 halves times what number equals 60. And the way I'm going to get rid of negative 3 halves is I multiply by the reciprocal, which is negative 2/3. Negative times negative is a positive, and 2/3 times 3 halves is 6/6, which is 1. So I just take it out, and I'm left with x on this side. And you can do this in your head. Simplify. 3 divided by 3 is 1, and 60 divided by 3 is 20, and 20 times negative 2 is negative 40. But I was showing you can also use your calculator. 60 times negative 2 divided by 3, and we get negative 40. And then show your check. Negative 3 times negative 40 is negative 120, divided by 2 is 60, and 60 minus 53 is 7. So you absolutely know you're right. All right, so that's that same problem again. And just always make sure you check your answer. I don't know where this extra CK came from, but just take it out. And I just showed you how to do that. Okay, and then just always simplify before you solve. So this was a problem we worked on. So Valerie was working at the zoo. She makes $10.80 per hour, and then every day she works, she also gets $8 for her meals and $3 for transportation. Last Saturday, she received $83.90. And my question is, how many hours did she work? So if we just define our variable, let's use H because we're looking for how many hours she worked. And I said in H hours, how much did she get paid? And that threw some of you off, so we came back to, well, in 1 hour, she would get $10.80. In 2 hours, she'll get 2 times $10.80. In 3 hours, she'll get 3 groups of $10.80. So in H hours, she'll get H groups of $10.80. So you just multiply her money per hour times number of hours. And then you wrote an equation to represent that. So let me see if I have that on the next slide. Yeah. So we had $10.80 H plus 8 plus 3. So her meals and her transportation is 11. And that totaled $83.90. So once you've added your 8 and 3, you've simplified this, and now we can solve. Subtract 11 from both sides your equal sign, your equation, and then we have 10.80H equals $72.90, and we undo this by dividing by $10.80. Divide by $10.80, and we get that she'd have to work 6 3/4 hours. And then we showed our check for that in class, and it worked. So now we're looking for n, and we know that the area of this big rectangle is 94 square centimeters. So we're looking for the value of n. And this is another example where we need to simplify this before we go and solve it. Well, we know that this little rectangle is 3 times 4, and you multiply length times width, so we know that's 12. And we know that if this is 4, then the width of this same width of a rectangle is also 4, and the length of this part is n plus 10. So the width is 4 times n plus 10. And I put that in brackets on purpose because remember you have 4 groups of n and 4 groups of 10. You must distribute the 4 to n and 10. So that's 4n plus 40, and we know that the sum of this area and this area is 94. So the next step we do is we put together our like terms. We can put together 12 and 40 because those are both just numbers. And now we have 4n plus 52 equals 94. And now we solve that. Subtract 52 from both sides. We're left with 4n equals 42. Divide both sides by 4. That's a 1. Take it out. That's a 0. Take it out. And 42 divided by 4 is 10 and a half. And then we go back and show our check. If n is 10 and a half, 10 and a half plus 10 plus 3 is 23 and a half centimeters long, and it's still 4 wide. And 23 and a half times 4 is 94 centimeters, so we know we're right. All right, and then I just wanted to warn you, be careful that these are all the same equation. They just look different. So all we did here was switch the order on each side of the equal sign. So we just took our 7 and put it on the right, and our 3x minus 2 and put it on the left. And here, all we did was switch. 3x minus 2 is the same thing as negative 2 plus 3x, and then we just switch sides of the equal sign. So I said they're all the same. Find x and use a check to make sure it fits each equation. So we know we add 2 to both sides here, and then we have 9 equals 3x, so x is 3. 3 times 3 is 9, minus 2 is 7. 3 times 3 is 9, minus 2 is 7. 3 times 3 is 9, negative 2 plus 9 is 7. And negative 2 plus 9 is 7. So they're all the same. And then you did this practice on your slates and showed me your steps. And all of you did this pretty well. You added 23 to both sides first. You always undo that addition or subtraction. Then we multiplied both sides by the reciprocal of 2/3, which is 3/2. This is all a 1. Take it out. 1 times x is x. And 10 times 3 is 30. Divided by 2 is 15. Our check. I can simplify this. This is 1 because 3 divided by 3 is 1, and 15 divided by 3 is 5. And then it's easy to see. 5 times 2 is 10. 10 minus 23 is negative 13. I know I'm right. Cool thing about algebra equations. Here was a new problem. You subtracted 24 from both sides. multiplied both sides by the reciprocal of negative 3/5, took out your 1's, took out your 0. We get x equals negative 30. This is 1 when I divide by 3. This is 6 when I divide by 3. And negative 5 times 6 is negative 30. And when we do our check, negative 3/5, we just put our 30 back in our original equation, our negative 30. And this is 5. This 5 divided by 5 is 1. Negative 30 divided by 5 is negative 6. Negative 3 times negative 6 is a positive 18, and 18 and 24 has to add to 42, and it does. 12 carry 1, 42. So we know we're right again. All right, and whoops, I don't know what happened, but I suddenly went back several. Okay, we did that one. We did that. No, that's the last one. Sorry. Add 32 to both sides. Multiply both sides by the reciprocal of negative 5/8. Simplify, and we get x is negative 80. Show your check. Negative 5 times negative 10 is 50, and 50 minus 32 is 18. Same two steps for all of them. Undo addition, subtraction, then undo multiplication or division. And when you undo multiplying by a fraction, you actually just multiply by its reciprocal, which is the same thing as dividing by negative 5/8. To divide by a fraction, you multiply by its reciprocal. So we're just taking out that step to make it faster. All right, and then you have this practice to do in your book, and 4 hours of ALEKS by Sunday night, 20 topics for those of you that haven't finished your green or orange slice of the pie, half for those of you that have. Have a great weekend.